Hi friends, welcome to Electrical Mind. Hi friends, welcome to Electrical Mind. Today I am here to say about discuss about the topic from electrical machines. Electrical machines. So in electrical machines, generally we have the special motors and general motors. What are the general motors and what are special motors? Let's see. General machines are four types. They are synchronous machines, DC machines, induction machines, transformers. These are the general machines. Apart from these four general machines, we have some special machines, special motors. These special motors are specially designed for some special applications, so that's why the name is known as special motors. These special motors are also four types. They are, first one is servomotors. Second one is stepper motors. Third one is universal motor, and final one is BLDC. BLDC means brushless DC motor. These are the four special motors. So writing, so I have a notes of so first let's discuss about the servo motors. So I have prepared a notes for the servo motors, so let's see that. So here about the special motors, I already told that special motors are designed for the special characteristics and for some special applications. So four types: servo motors, stepper motor, universal motor, BLDC motor. So servo motor. A servo motor is a rotary circular motion rotary actuator. Rotary actuator means circular motion, and or linear actuator. Linear actuator means linear motion. So what about this is a servo motor? Either it can be a rotatory motor or linear motor. Means linear means straight going path. So if it can rotate with great precision value. Great precision value means exact value or accurate value is called great precision. So this type of motor consists of circular control circuit. In this servo motors, we have the control circuit that provides feedback. Where control circuit. This control circuit provides feedback on the current position. Current position means present position of the motor shaft. Where the motor shaft is in present position, it will give the feedback. Then this feedback allows the servo motor to rotate with great precision value. This feedback from the control circuit, which we are getting the feedback from the control circuit to the motor shaft. With that feedback, the motor will rotate with great precision value. So next point is, if anyone of you want to rotate an object or anything, or a object or applications, or we have to apply it for applications at any specific angles or distance, then we can use these servo motors. These servo motors are mainly used for if we want to rotate any object at any angle, at any specific angle, or for suppose if we want to rotate this motor at 90 degrees, then exact 90 degrees only it will rotate. So for this exact rotating angles, for exact special design, for this special design we use the servo motors. So the mechanism that we have in this servo motors is servo mechanism, what we call servo mechanism. What is a servo mechanism? What is servo mechanism? It is an servo mechanism means it is an electromagnetic device which converts electricity into precise controlled motion by using negative feedback mechanism, which use negative feedback as the negative feedback. This is called servo mechanism. So next point is these servo motors are of two types. What do we call is AC servo motor and DC servo motor. The power supply which we give AC supply is known as AC servo motors, and the DC supply we give is known as DC servo motors. A servo motor usually comes with gear arrangement. So gear arrangement means I have already drawn the this is the diagram of the servo motor. This consists of the gear mechanism. So gear arrangement that allows us to get a very high torque. Why we use the gear arrangement in this motor is, if we want to get the high torque, we use the gear. If suppose these gear systems we use in car, bikes, etc., in buses, etc. In vehicles, all we see this gear arrangement for starting purpose, for high torque. So next point is servo motors are usually small and lightweight. These servo motors are very small. And these are very lightweight. It's not like a transformer. We can't lift the transformers with single hand. So likewise these servo motors are of lightweight. It is very small and lightweight. So these servo motors are main applications are used in toy cars, RC helicopters, planes and robotics. Robotics. So the next point is servo motor working mechanism and principle. This servo motor consists of three parts. What are the three parts? Controlled device, output sensor and feedback. So this I already said the control device which produces the feedback to the motor shaft. From this control device only we will get the feedback to the motor shaft at current position. So it is a closed loop system where it uses a positive feedback system to control motion and final position of the shaft. So it is a closed loop system. The device is controlled by a feedback signal generated by comparing output signal and reference input signal. In this device, this device is controlled by the feedback signal generated by comparing output signal and reference input signal. So here this reference input signal is compared to the reference output signal. In this reference input signal is compared with the reference output signal. Third, by comparing these two signals, we get the third signal is produced by the feedback system. So So this third signal acts as the input signal to the control device. So this reference input signal or reference output signal is not the input signal of the device. When we compared these two, this reference input signal and reference output signal, we get the third signal which is produced by the feedback system. This feedback, the signal which we get from the feedback system acts as the input signal to the device. So this third signal is present as long as the feedback signal is generated or there is a difference between reference input and reference output signal. So what this point says about this point is saying about this third signal is present as long as the signal is generated. As this third signal, whenever the feedback generates the signal or the difference between the reference input signal or reference output signal, when there is a difference in between the input and output reference signals, or as long as the signal is generated, until the time the signal is generated, the third signal acts as the input signal. The third signal is present as the input signal. This third signal is main task of the servo mechanism. The main task of the servo mechanism is to maintain the desired value constant. We should maintain the desired value constant in this servo motor, in this servo mechanism. So let's see the working principle. The working principle of the servo motor consists of the DC or AC. A potentiometer, gear assembly and a controlling circuit. In this we use gear assembly to reduce the speed. RPM means the units of speed is RPM. So to reduce the RPM and to increase torque of the motor. The main purpose of gear assembly, gear we use is to reduce the speed and to increase the torque. The main application of this servo motor is to get the high torque. So that's why to increase the torque and to reduce the RPM, we use the gear assembly in this servo motor. At the initial position of servo motor shaft, the position of the potentiometer knob is there such that no electrical signal is generated at the output port of the potentiometer. So when there is no output, when there is no electrical signal is generated from the potentiometer knob. So when the electrical signal is given to another input signal of the error detector amplifier. So what happens is, at initial position in servo motor, we didn't give any electrical signal to the potentiometer knob. So now we gave the electrical signal to the input terminal of the electrical detector amplifier. We give the electrical signal to the detector amplifier. So the difference between these two signals, so now the difference between these two signals, one comes from the potentiometer and another from other sources, will be processed in a feedback mechanism and output will be provided in terms of error signal. So what happens is, the two signals, we are getting two signals. One comes from the potentiometer, one is coming from the potentiometer and another from the other sources. So that what happens is, the feedback mechanism and output will be provided in terms of the error signal. So this the signal coming from the potentiometer and the signal coming from other sources both combined, the output we get is error signal. Both we get is the output will be error signal. This error signal acts as the input for the motor and motor starts rotating. Whenever the signal comes from potentiometer and the another signal coming from the other sources, these two signals will give the one output signal that is called as error signal. This error signal is act as the input signal to the motor. This input signal to the motor, servo motor. So when this error signal is given, acts as the input to the motor, then what happens is motor starts rotating. Now motor shaft is connected with the potentiometer, and as the motor rotates, so the potentiometer will generate a signal. So this point, what this point is saying is, the motor shaft is connected to the potentiometer. This motor shaft is connected to the potentiometer and the motor rotates. So the potentiometer will generate a signal. So whenever the motor shaft is connected to potentiometer, the motor starts rotating. So the potentiometer will generate the signal. So as the potentiometer angular position changes, so whenever the potentiometer's angular position is changing, its output signal changes. So whenever the potentiometer's angular position, the position is changing, the output feedback signal changes. So after some time the position of potentiometer reaches at a position that output of potentiometer is same as external signal provided. So after some time the potentiometer reaches at a position. After some time the angular position changing, it reaches to a position. It reaches to a position. At that point, the output of the potentiometer, the output that comes from the potentiometer is same as the external signal provided. External signal that provided in the servo motor, and the position and the signal that from the potentiometer is same at when the potentiometer reaches at a certain position. So at this condition there will be no output signal. Whenever the external signal and the position of the potentiometer reaches at a position, the output of potentiometer and the output of the potentiometer and the external signal is same. Whenever these two are same, at that time what happens is motor stops rotating. At this condition there will be no output signal. Whenever the potentiometer reaches at a certain position, the output potentiometer is same as the external signal provided. Same, the position, the output of the potentiometer and the external signal are same. When these two are same, in this condition no output signal is generated from the amplifier. Where we are getting the signal output signal is from amplifier. In this condition, whenever the potentiometer reaches a position, the output of the potentiometer is same as the external signal provided. In this condition, no output signal, we don't have any output signal from the amplifier. So at this condition what happens is, signal generated at potentiometer, this situation the motor stops rotating. Why means the to the motor input, as there is no difference between the external applied signal and the signal generated at the potentiometer. When there is no change or no difference, when these two potential, the signal from the potentiometer and the signal from and the external signal is same, when there is no difference and it's the signal, whenever the signal is same, so that in this situation, in this condition, the motor stops rotating. This is the principle, servo mechanism and principle of the servo motors. So this is the amplifier. This is where we give the supply AC or DC. This is rotor. This is the gear system for high torque, to get the high torque. So this is the starter, control, transformer. So this is the servo motor amplifier. This is where we give the control signal. This is of the control winding and motor shaft. Motor shaft is connected to the potentiometer. This is the main winding. So this is about the servo motors. So these servo motors mainly we use it in the applications for the low speed and high torque applications, to get the desired value. For desired value we use the servo motors. The main applications are toy cars, helicopters, planes and robotics. These are the applications of the servo motors. For special design, for special angle, for special angle, to rotate the object at any angle at specified value, specified distance or specific angles, we use the servo motors for these applications. So this is about the servo motors. So if you like my video, please share, like and subscribe to my channel. Thank you for watching.